In this problem, we're looking for all of the angles in radians between 0 and 2 pi that would satisfy this equation. And as it is right now, there's not a way that we could solve this algebraically without rewriting the left side. So right away, I'd recommend looking at a graph where I have this orange sinusoid is representing this linear combination. And so whenever I add or subtract two functions, a cosine and a sine of the same period, it will result in just another sinusoid. I'm looking for where that would equal 5 in between 0 and 2 pi, and so I can see I'm going to have two different answers, one in between pi over 2 and pi, and then one in between pi and 3 pi over 2. So we learned in class how to rewrite a linear combination like this. And so to start, I'm going to look at the amplitude of cosine, which is negative, and the amplitude of sine, which is negative. And I know that sine and cosine are both negative in the fourth quadrant. So I'm going to draw myself a reference triangle down in the third quadrant. From here, the x value is -7, the y value is -2, and our amplitude is going to be the hypotenuse, or the radius here. So we can use the Pythagorean theorem to find the amplitude. And so we will end up getting the square root of 53 for our amplitude there. So then next, we need to find what this larger angle is, and that's going to give us our phase displacement. And so I'm going to go ahead and take the tangent inverse, opposite over adjacent, -2 over -7. You'll want to make sure that you're in radian mode. And I will end up getting 0.278 radians. Well, that puts me in the first quadrant, but we know that our angle needs to be down in the third, and so I will add 80 to that answer to get the correct, add pi to that answer to get to the correct quadrant. So we'll get 3.4198. And so I'm going to rewrite this as a cosine, and we did this in class, and we have a couple videos that you can watch too if you're confused on what we're doing here. But my amplitude is the square root of 53. It's a cosine function that has been displaced, not 2.78 radians, but 3.41, and we'll go 99 for now. And we're looking for where this equals 5. So from here, now that I have this in terms of a single trig function, I can solve this equation by first dividing both sides by the square root of 53. And so I will get the cosine of x minus 3 and I'm going to go ahead and round that to 4.2, will equal 5 over the square root of 53. So next, what I'm going to do is I need to take the cosine inverse and find at what angles will it equal this ratio. Like the quadrant. So when I take the cosine inverse of 5 over the square root of 53, I'm going to get one of the answers, which is 0.8137 radians, where with cosine, if I know one answer, I know that the negative of that will also be a solution. Well, that's what the inside of the cosine needs to equal, so I'm going to rewrite this as two separate answers. So we have x minus 3.42 needs to be approximately equal to 0.8137 radians. X minus 3.42 would also need to equal negative 0.8137 radians. From here to solve for x, I'm simply just going to add over that 3.42. And even though I'm rounding when I'm writing this down, I would recommend using the entire answer in your calculator just to make sure you don't run into any rounding errors. And I get x is approximately equal to 4.234. And again, that's in radians. I'm going to take the negative of that 0.813 number. Same thing, add that 3.419 number. And my other solution will be 2.606. We knew we were only looking for 2 answers in this specified domain, and so we are now done.